Hey everyone, thank you so much for watching the Weaviate Podcast. I'm super excited to welcome Aleksa Gordcic, Andrei Bondarev, Stephanie Horbacheski, and Gunjan Bhattaraev, Yana Wellander, Greg Kamrat, and Colin Harmon, Emil and Finn, Professor Laura Dietz, Brian Raymond, Erica Cardenas, Siva and Roman, Yusheng Wu, John Dagdalen, both Weaviate co-founders, Bob Van Light and Etienne Dillacker. Hey everyone, thank you so much for checking out this update on the Weaviate Podcast Search. Hopefully from the introduction reel you saw that our next Weaviate podcast is going to feature Aleksa Gordcic. Aleksa has such an interesting story of beginning as a YouTube content creator making deep technical paper summary videos, then joining DeepMind, the top AI lab in the world arguably, and then leaving DeepMind to start Ortus. So Ortus is about creating these next generation content creator tools. So building question answering or chatbots over particular YouTube channels, like say Jeremy Howard's YouTube channel and ideas like this. So this really inspired me to give an update on what I've been doing with the Weaviate Podcast Search. I've been taking these podcasts, putting them into Whisper, and then taking the transcripts and searching through them. And now with large language models and generative feedback loops, I think it's right for an update. So generative feedback loops, broadly, the idea is where we retrieve data to pass to the large language model, and then we save the resulting generations from the large language model back into our database. So there are two really kind of boots on the ground, immediately useful applications of this, which is firstly, to write a summary of the podcast, and then secondly, to identify the chapters in the podcast. These are just like two tasks you have to do every time you upload a podcast as you're managing something like a podcast. But at the end of the video, I want to conclude with some, I think, directions for future work that can really take this to the moon. I think the future of content creation and consumption, this kind of, video, YouTube, podcasting, I think all this is just going to totally flip on its head with large language models and all this cool, exciting stuff. So I hope you enjoy the video. We're going to start with some code, and then we're going to conclude with some kind of big ideas about where I think this is going. So thanks so much for watching. Before diving into it, all the code for this project has been open source on GitHub, Weaviate Podcast Search. All of the data, the podcast transcript, JSON files can be found in this data folder. The generative feedback loops folder has all of these different scripts for writing the clip summaries, the auto chapters, the full podcast summaries. Recommendation is a demo that I did at ODSC East, where you show ref to vec through the different podcast clips, as well as searching with the ref to vec vector, and then doing retrieval augmented generation with the nearest neighbors to the user vector. Chat vector DB LangChain, that's from Erica's blog post. So if you want to chat with this podcast, this is how you do that. And then some other things like how you do a Weaviate backup, or how you get the data out of Weaviate into a JSON with the Cursor API, how we create the schema, which we'll get into right after this, and then all sorts of things from how you upload the data and miscellaneous cool things. So if you do check this out, please leave a star. It means the world to me, and I really hope you enjoy this. This video will show you how you can apply generative feedback loops to the Weaviate podcast transcriptions. So when we first presented generative feedback loops, we had the example of Airbnb listings. We had a data set that mostly contained tabular symbolic features like the number of bedrooms in the Airbnb listing, what neighborhood it's in, the minimum number of nights you needed to stay in, and so on. And so the first thing we did with generative feedback loops is we took this tabular data and then we put it into a prompt that wrote a text description of the Airbnb listing, which we could then vectorize with, say, the zero-shot OpenAI or Cohere models, and then embed into our Weaviate index to search through. Another thing that we did with generative feedback loops in this first presentation was we took these summaries and then we wrote a personalized summary by retrieving from a user class that had, say, Connor, who likes to travel with his dog, or Bob, who needs a powerlifting gym when he travels. So we showed kind of two things of how you build this index out of tabular data by retrieving data from the database, feeding it into the language model, and then saving that generation back into the database, as well as retrieving from another class, and all this kind of ideas of how we take data from our database, put it into a language model, and then save the resulting generation, because we're going to want to use it in the future. So I'm so excited to show you how I've been using this concept for the Weaviate Podcast Search. Maybe you're working with a similar data set, or maybe this will just kind of inspire your thinking on what generative feedback loops are capable of and the role that this will play in the future of generative models, vector databases, and all this cool, exciting stuff. So we're going to start off with the data schema showing how we design the classes, properties, cross-references for this particular example. Then we're going to build a summary index of clips where we take the raw, what was said in the podcast, and we transform it into a summary of the content that was said. And then it's actually better to search through this summary index, the vectorized representations of the summaries, rather than the vector representation of just kind of the raw transcript. So we're going to be saving these summaries back into the database and then using these summarized clips to feed into our summarization chain for the entire podcast. So it's a nice example of where we save something back into the database to then keep feeding it into future chains, and this whole idea of this kind of cascading generations that we save back into our database. So we're also going to use the clips to do the chapter segmentation, auto chapter analysis at the end as well. So finally, after the video with the practical, just the hands-on examples with that we see the results and we've tested things, I want to present some future direction. So here's the data schema for the Weaviate Podcast Search. We have 3 classes: PodClip, Podcast, and Chapter. Highlighted in green is the property that's used to vectorize each instance of the class. So for every pod clip, we have a clip summary text property, and that's what's passed into our vectorizer model that produces the vector that will represent each instance of the podcast clip. Similarly, for the chapters, the description that's written will represent the chapter. The description will be vectorized to represent each individual chapter. Each description is vectorized. Sorry if that's too redundant. And then with the podcast, the summary will be vectorized. So also shown in red are the data types for each property. So content is text, speaker is text, pod number is int. There's some interesting things you can do when you're indexing text to use as a category. So for example, with speaker, we might want to use that as a categorical variable rather than like a text thing. So you can configure this in Weaviate to have the inverted index on using speaker as a categorical thing. If you want to query like where speaker equals Bob Van Light or Eddie and Dillacker or something like this, so you can do that with these text properties. So similarly, you can do duration to have like a filter on, say you want to only see chapters that are longer than 5 minutes because or longer than, let's say, 10 minutes because that's more likely to be, I don't know, maybe a deep discussion. I'm not sure, but you can use these properties to filter your vector search. So as you're searching through the vector representations of the podcast clip, you can also add these filters as well, which is something I always found was so interesting about Weaviate, is this combination of filtered vector index traversal. So additionally, we have cross-references between classes. So the way that this works is you can first search for a podcast that matches your query, and then you can see which clips are contained in the podcast to then get out the clips, or so on. You could link chapters to pod clips and all sorts of other stuff. I think there's an interesting discussion to be had about representing podcast classes with the summarization chain versus ref2vec, but first let me show you the example of the summarization chain and then we'll come back to that discussion. So I hope this is a good description of the data schema that's going to be used for this example. Now let's see quickly the JSON dictionary that you use to create it in Weaviate. So we'll start off with a quick look on how to create these schemas with Weaviate. So the first thing we do is we connect to the Weaviate client wherever this is running. In my case, I'm just running it locally on this laptop, but you can also have Weaviate embedded or say the Weaviate cloud service, running it yourself, these kind of things. So first you connect to your Weaviate instance, and then you define the schema dictionary where you have the different classes that you want to create. Again, we want to create 3: PodClip, Podcast, Chapters. So with chapters, we're going to turn on the text-to-vec transformers to vectorize each instance of our class, and then we're also going to enable the Generative OpenAI to do that thing where we are going to parallel. I'll get into this more later, but we select which model we want to use. In this case, I like the TextDaVinci 003. So here's the next interesting thing is we're defining our properties. So see summary versus content. In this case, we have skip false. This means we're going to vectorize the class based on summary, whereas content, we're going to skip this. We're not going to vectorize content. Speaker, we're going to skip as well. And speaker, I did mention that you can have this, you can enable inverted indexing on text properties to use them as categories. I haven't done that quite yet, but just quickly noting that this is where you would do that. So after you define all the kind of, text in date, these normal properties, now we define cross references. So we have in podcast, which is the data type podcast that we're about to define. And you have in chapter with chapter that we're about to define. So I don't think there's anything else too novel about this. Podcast, again, we skip the other properties. We only vectorize the summary. These are kind of older properties I had when I was originally working on this. But so has clip, has chapter, time start, time end, so on. So now that we've defined our data schema, we're going to be uploading the data that we do have, and keep in mind that a lot of this data in the schema is going to be produced by an LLM that we're then going to save back into the database. But we start off by looping through this original data where we have, say, the content, the speaker, and the podcast number, and then we're also going to be creating a clip number key that we're going to be using later to get the clips out and put it into the file. So we're just going to be creating these objects, creating cross-references between PodClip, in podcast, and podcast has clip, PodClip, and that's all we're going to be doing for now. And we're going to be creating a lot of this data again with our LLMs. Okay, so now that we've defined our schema and imported data into Weaviate, we're going to be summarizing each of the raw podcast clips into a summary. And quickly, before I show you the prompt to use that, let's have a look at the final result, maybe just to wake you up if we've been diving into the code too much. So what we're doing is, again, so for each of these, each of the contents, we write this summary. So maybe we can take a look at how well that works. So in this clip, we are talking about competition and this paper summary. So Connor Shorten agrees that markets are underserved and competition is a big force that can show ideas. He gives credit to the speaker for diving into graph neural network stuff. So that was a pretty good summary. Here's another one, or let's see one that maybe has more content to it. Okay, so this is Aleksa talking about, I already felt fairly comfortable. So this is Aleksa talking about how he got to DeepMind. So then the summary is, Aleksa Gordcic began his journey into machine learning in 2018 when he attended a summer camp organized by Microsoft. He was inspired by the lectures from DeepMind and wanted to be at the forefront of AI development, so on and so on. So this also is a pretty good summary. So basically you get the idea of how you see how these summaries are like, more compressed, information packed than kind of, just raw how people speak. And I think this is a really interesting component of this because you vectorize this to represent the classes and then search through, and it gives you a better vector because it's cleaner data. So we're kind of using like the large language model to clean our data. And there's all sorts of interesting things. There is an interesting paper on using these to supervise training embedding models, the summary and the original content as the positives. A lot of interesting stuff to this. So let's get into how we do this. Okay, here's the code to write a summary for each of the podcast clips and then save the resulting summary back into Weaviate. So we start off by connecting to Weaviate. Then we write our prompt to use the Weaviate Generative Search module. Generate prompt, please write a short summary of the following podcast clip, speaker, and then we template in the speaker value, podcast clip, and then we template in the content value. So then we select the properties that we want to select from the Weaviate class to put into the prompt. Then this is something I did. I originally had a loop, but what I found is it costs about $1 to do this. So if I did it for all, I think 15 podcasts in there. So I'm just doing one podcast at a time for the demo. So a podcast equals 55 and, just putting it into the where filter template. So first we get the total clips. And again, I just kind of hard coded that in quickly, but so then we get the total clips in the podcast. Now we're going to be looping through the clips with this offset. So the way that this works is Weaviate has built in this generate search module into Golang, which makes it really good at handling these parallel Golang requests, which makes it really fast. But if you try to put in like all 70 clips at once, you're going to end up getting a read timeout if like one of those requests takes too long and so on. So I did this 10 at a time by using the following, where you loop through the clips with this increment of plus 10 step sizes, and then with limit 10, and then with offset. So the offset just pushes it, through the data objects. So so you just grab the podcast clip, you sample the generate properties, then you pass it into the prompt defined above, and it's pretty much as easy as that. You get the ID out, and then this is just what I did to kind of monitor how it's going. And then you just update the data object by creating this new property for each of the summaries with the summary, and then the generate single result that comes out of the prompt. You get the ID, and then you update the data object with this new property, the class name, and then the UUID for this object. Okay, so next up is to write a summary for the entire podcast by using a summarization chain. So firstly, again, we connect to Weaviate. We'll pass in our OpenAI key here because we're going to do this just with the OpenAI API here in Python, because we're doing it sequentially rather than parallelizing the requests across the search results. So we just pass in, this is just a little wrapper. I found that I actually prefer the results of DaVinci to 3.5 Turbo. Maybe someone has a comment, but I didn't explore it that much. So temperature 0, passing in the prompt, max tokens, and all this kind of stuff. So first thing to do is to get all of the clips, and again we want the summaries, not the original content. So we get these clips with our Weaviate query, And then what we're going to do is this local memory create and refine prompt. So maybe hopefully that's, you can see that well, but so we start off with an empty string for the current summary, and we have the prompt, please write a summary of the following podcast. You will receive the clips one at a time, as well as a summary generated so far, current summary so far, and then we put in our local memory that we're going to keep writing by saving the output of this call back into that current summary variable. In the next podcast clip, speaker, speaker, and then you put in the next clip, speaker said content. So we're looping through the clips, putting in the speaker said content, as well as our local memory of the current summary of the podcast so far. So hopefully that makes sense. So then what we do is, so what would happen with this originally is it would just keep adding sentences onto the end of the summary. So, then you end up going over the 4096 token window. So in the middle of this, while you're looping through the clips, you then have, please rewrite this summary to make it shorter. Please be careful about losing too much information when rewriting. I found that kind of works, that second thing of, but because I think the current limitation of this is that it often will compress it to just writing these long lists with commas of each of the things. And, that's not great for the summary, but so there are some interesting ideas, but this is the first thing I tested is this kind of summarization chain thing. So you just continue looping through that, again, printing it just so I can see it as it's running in the console. And then saving it. So we get the podcast ID that we want to be linking as we're saving back into the podcast object. So we add this new summary property, and then we update it by putting in the summary that comes out of this, that current summary object as we've exited the loop, and then we pass in the ID. So I think the first thing to note about running this is about how you're going to be visualizing it, and maybe there's an opportunity for a startup. I've heard of tools like Langflow and things like this. I just haven't personally had the time to get into it yet, but this is what I've been doing is just as it's looping through each podcast clip, it takes that first podcast clip, it writes the summary of the whole podcast from it, then it rewrites it, and I'm just kind of printing it to the terminal, and I'm just watching it on the side as it runs. And so I do think that you get a pretty good debugging with this. Like I've learned from just watching this that when you rewrite it, often the ways that this fails and the reason why the resulting summary is like okay is because it'll compress it into like a list, like just like commas to describe terms. And I mean, at the end of the future work, I want to talk about this kind of general understanding and how that clearly doesn't understand what it's talking about really. And I think there's a lot of I think that's quite an interesting point. But anyway, so just the practical example I want to show you is just logging it to the terminal to visualize the chain. Honestly, I think this gets the job done, but I can't imagine with complex chains and when you're really looping and then branch, like each loop has this kind of nested, like, summarize and then rewrite. I could imagine maybe you want these more advanced tools for visualizing these kind of things. So now let's get into what I think is the most interesting task for these generative feedback loops to be doing, which is to automatically identify the chapters in the podcast. This is probably the most useful time-saving thing about this to be doing. So again, we start off with all that same kind of connect to Weaviate and define this OpenAI thing, and there's probably a cleaner way of doing this, but I don't think it matters for this. So again, we get the podcast clips out, and now we're going to be looping through these clips. So here's the interesting thing. So we start off with this empty dictionary of chapters that we're going to be putting in these dictionaries to. So we're going to have a list of dictionaries. Then at the end of the loop, we'll loop through this list, and then we'll take out these dictionaries to write the key values into the Weaviate data objects. So we have the keys chapter and then start and end, which is going to be huge for how we then use this to annotate the podcast. And then we have the pod clip IDs to create those cross references from pod clips to chapters, and then inversely chapter has pod clip. So here's the prompt that I found to work okay with this, and hopefully you'll find this interesting. So your task is to annotate chapters in a podcast. You will receive a podcast clip and the current chapter topic. If the conversation in the clip discusses the same topic, please output 0. If the content in the clip is very short, such as a joke or a thank you or something minor like this, please output 0. However, if the conversation in the clip discusses a new topic, please output 1. The current topic is, and then you template in the current clip that you're at. You will receive the current clip as well as the previous and next clip for additional reference. So previous clip, next clip, current clip, and then you put the current clip again twice. As a reminder, please only output either 0 or 1 as described above. So I think there are kind of two things to this prompt that make it interesting. The first of which is showing how you can have this if else just in natural language to have it, if this kind of natural instruction. I find that to be very interesting. And then I think this is the idea behind structured output parsing. There are, more nuanced things you can do, like where you output JSON dictionaries and then you have like JSON.loads and then you parse out the key and things like that, where it would, kind of generate like multiple things with one call. But generally, I found this to work surprisingly well. Every time I tried this, it did only output 0 or 1, and I just, see how I wrap the response in an int typecast. So I didn't find that it broke it, or that it said, new top, like say it would write new topic instead of 0 or 1 and not follow the instructions. I found that this worked pretty well. So then what you do is, if topic response equals 1, now you're going to cut the ending of the current topic, append this dictionary to the chapters, and now you're going to be creating the new chapter object. So you have this, please write an abstract description of the conversation topic discussed in the current podcast clip. For the sake of reference, you'll receive the previous and next clips as well to help further contextualize, the abstract description of the topic. So again, passing in the previous, current, next. Please write a maximum 6-word description of the conversation topic discussed in the current clip. So again, we template all this stuff, and then we, save the output into our chapter for the current topic, which is what goes into what goes into the current topic template. So earlier I misspoke and said that this was here as well, but this is actually the current topic, obviously. But so anyway, so then we exit the loop, and now we're going to be saving the new chapter objects. So first we get the podcast ID that this was sourced from with this query, run this. And then, so then we have the for chapter and chapters. We're looping through that list of dictionaries. We have our properties that we extract the chapter, the start, the end. Then we get a UUID for this chapter ID. We create the chapter object. And now we're going to link from pod clip in chapter, chapter has clip, pod clip, chapter from podcast has chapter. So that's how we, again, connect that graph full of cross references to add this structure to our data. So that's all we need to extract these chapters from our podcast. Okay, so we're similarly going to just kind of visualize this in the terminal, which I've found to be a fine solution for this. So what it's doing is it's executing that if we need to switch the topic or not. It starts off with building a YouTube channel, explaining ML concepts through videos. Then it transitions to, stays on that one for a while, creating a startup ordis, and so on. So this is the idea of it executing this if-else logic with the topics as it passes in these topics by looping through each of the clips and having that if-else kind of prompting, and then the structured output parsing of if 0, if 1, and then how that leads to being able to automatically create these chapters in the podcast. Okay, so that's the end of the latest update on how far I've made it so far with summarizing the clips, then applying a summarization chain on the clip summaries to summarize entire podcasts, as well as extracting chapters from the clips. So again, it would mean the world to me if you check out the GitHub repository that contains all the code for doing all of this. You just need to replace your OpenAI key, but maybe you're probably just more interested in seeing the example and then applying it to whatever data set you're working with. So anyway, so here are some directions I think of what I want to do next with this project that I think are really interesting, and I think you'll find that interesting as well. So starting off with topic modeling for podcast summaries, I really want to show you this atlas map, and I think that topic modeling, where you cluster the clips and then you look at the clusters, could have a nice structure instead of this kind of sequential summarization chain. I don't think this sequential summarization chain is going to be the best way to summarize these podcasts going forward. Then I want to talk about self-ask prompting. We're usually thinking about it with question decomposition, but I think it's really interesting for summarization as well. I want to show an idea that I've been learning about from Llama Index on retrieving from multiple information sources. I think there's a lot of nuance to this. And then I want to talk about personalized summaries, podcast to blog posts, and generally how working on this project has led to a new understanding for me on fine-tuning LLMs, and hopefully you'll agree or have some feedback on what I'm getting wrong. Okay, so what you're looking at is Atlas from Nomic AI, which is a visualization of embeddings projected into a lower dimensional space so that we can visualize the clusters. You see these high-level tags: generative adversarial networks, neural architecture search, topic modeling, which is funny because that's what we're talking about. These are the high-level descriptions given to these categories. So this is a pretty big topic map. As you see in the title, this is all of the abstracts of papers and NeurIPS from 1987 to 2022. But you could imagine doing this kind of thing. So if we zoom in on the generative adversarial network thing, Like imagine all the podcast clips are like this and they have some kind of cluster structure within the clips. And then, so I think summarizing each of the clusters and then just kind of merging them into the one summary from the podcast, I think most likely that's the best way to summarize long content with these LLMs going forward. So the first thing I want to do next is add in a prompt when it's summarizing the podcast clip to ask, do you need more information, more background knowledge about certain terms that you're summarizing? So one thing I noticed just from watching the summarization chain in the terminal is that it doesn't understand, say, what graph neural networks are, and so it'll combine the graph neural networks thing into the discussion of like just creating YouTube content broadly in a way that totally doesn't make sense. It demonstrates no understanding of what graph neural networks are, which brings me to the last thing on fine-tuning LLMs. But I think this general idea of in question answering, it makes quite a lot of sense. Who was the president of the US when superconductivity was discovered? And then you ask when was superconductivity discovered, and then in that year who was the president. So you break up the question. I think summarization chains should adopt the same perspective to how that works, which then brings me into a super interesting thing I've been learning about from Llama Index, which is about routing queries to different information sources. So purely from the vector, the Weaviate standpoint, I think just the idea of selecting from different classes. So say I have one class is Weaviate blog post, another class is like archive, and then say another thing is Wikipedia. And then if I want to retrieve about, I want to get like a definition of graph neural networks, say I retrieve that from archive. If I want to get some maybe definition on just like when machine learning was invented, maybe I get that from Wikipedia. But this idea of routing these queries to different information sources, I think this has huge potential in how this kind of summarization chains could improve and how you can retrieve from different sources to retrieval augmented generation, pack the prompt that facilitates a better summary. The next topic is quite different, but this is more so a bigger project. The kind of hopefully when I do generative feedback loops, Weaviate Podcast Search Part 3, I have this kind of thing ready where what I'm really dreaming of is to do personalized summaries. So you give it the chapters, maybe a short description of the chapter as well. Then you have something like, a list of people who are interested in the podcast, newsletter subscribers. So you have the chapters of the podcast, and you retrieve. Aleksa Gordcic is an entrepreneur building Ortis. Ortis is an interactive way to watch videos, learn faster by using question answering capabilities and high quality summaries. And the prompt is, which of these chapters do you think would interest Aleksa? If none, please output not interested. So then you write this personalized summary to email Aleksa to say, hey, do you want to watch this podcast? But if they're not interested, then, don't spam them. Don't send them an email for the podcast that they wouldn't want to watch. So I think this is this whole idea of this virtuous cycle, the aggregation theory from Ben Thompson. I think this is that thing, this, personalization of content. And this is particularly how I'm thinking about using it. So hopefully that's useful for you to see like a real world example of how I think this can improve our podcast and our content at Weaviate. So the next thing I think is super interesting is to write blog posts from the podcast. And I see kind of two ways of why this would be interesting. The first of which is to say, like, what is unique about this podcast? So please write an analysis of what this podcast says uniquely about chapter, and then you search within this podcast to get the top K from this podcast. And then you say, here are clips from other podcasts to compare if this podcast says anything unique. And then you do the top K from all the other podcasts, from all podcasts. And so I think that's quite interesting because now you have this comparison kind of thing that you're doing with the semantic search. So I really love that idea. Then I think another thing is, I like to listen to like David Sinclair and like these kind of like biology things, but I often I don't really know what they're talking about. So I think this kind of like retrieving from some information source like archive to write a background blog post. So, when I'm reading about like metabolic pathways or CRISPR or stuff like this, where I hardly understand any of it, having some kind of like pre-flight blog post for me before I listen to one of these podcasts, I think that could be really cool. This project transformed my understanding of large language model fine-tuning. So I think on one end, we're kind of just, waiting around, when is GPT-5 coming, or when is, Cloud or Cohere or some open source model going to just be this impressive model that can just somehow understand topics like graph neural networks, like specific things for your specific information needs. So it got me thinking about, you could imagine you take the prompts again, like please write a summary, current summary so far, and then, the local memory, and then the next clip, and the next summary, and it outputs some kind of next summary. And you would label that as I like this or I don't like this. And that's the general labeling framework of reinforcement learning from human feedback that makes this so appealing, is you just need to say like it, don't like it, and it can, do this sequence to sequence learning and update the language model. but I don't think that this will ever get you to that underlying language understanding. So on the top is kind of what I think is the conventional wisdom, that you would take some model that's already been trained with reinforcement learning from human feedback on like general preferences of writing summaries of things, and then you would just kind of try to like steer it in the direction of your domain by annotating this kind of thing. But I think the alternative idea is you have a pre-trained language model, and then you language model some of your data set, and then you do the reinforcement learning from human feedback. So this is really inspired by my thinking. The news of the time as I'm recording this video is Mosaic ML being acquired by Databricks for $1.3 billion. And I just recently recorded a video looking at the MPT 30 billion language model that they open sourced. And a detail of it that just blew my mind was the open sourcing of the language model and then the instruction tuning. It just really helped me separate these ideas. And I've had some conversations with Jonathan Franco on this podcast where he discussed convincing companies to language model their data. That's where you predict the next masked out token on, say I just took like all of archive, or I filtered it for information retrieval, approximate nearest neighbor search, like this kind of like Weaviate domain, just language modeled Weaviate podcast transcripts, blog posts, and so on. I think that then you would have this base foundation that then you could RLHF onto that. So I'm curious what people think of that. That's my latest understanding in what LLM fine-tuning might look like, and how this project kind of thinking about how might I get a better result from this kind of led me to appreciate that kind of continued pre-training concept a little more. Thank you so much for watching this latest update on the Weaviate Podcast Search and applying generative feedback loops to this data set to summarize clips, summarize podcasts, and extract chapters from podcasts. I think that these ideas of personalized summaries, podcast to blogs, overall, just for me at least, having a data set helps just cement all these kind of ideas and ground them in some kind of application. So please subscribe to this YouTube channel and leave a like on the video if you enjoyed it. You can check out Weaviate at weaviate.io. Also, it's an open source GitHub project, Weaviate/Weaviate. And also please follow on Twitter at weaviate.io. Thank you again so much for watching.